Let us discuss an important phenomena in case of energy band diagram of solid lattice structures, that is energy bands. How energy bands are formed, it is an important concept to be understood. For this we can write that in a single atom, we know very well that in case of a single atom, in single atoms electrons occupy energy levels which we also call shells. In different shells, electrons are filled in the surrounding of a single atomic nucleus, and we can write that in case of solids, an electron of one atom is also in the influence of the other atoms in surrounding. Due to this, energy levels are modified, because water energy we have already studied about an electron in the influence of a nucleus. It was due to the electric field only of one nucleus. But if there are more than one atoms in the surrounding, then obviously we can say that the positive electric field of other nuclei in the surrounding will also affect the potential energy of the electron of one nucleus of a specific atom. So here we can consider a specified example, like say if there is a nucleus and in the surrounding there are energy levels like this E1s and this is E2s, then next is E2p and so on. So these are the energy levels or shells in the surrounding of a specific nucleus, or these are the orbitals. But what happens in case of a solid lattice? This is the situation of a single atom. But if we talk about a solid lattice, we can say there is not a single nucleus and its surrounding there are other nuclei also exist. So when we talk about its first energy level, which is 1s, here we can see the electron which is in 1s orbital of this atom, its energy will be affected by the other nuclei also. So we can say the energy of electron which can reside in this 1s orbital is not a specific energy like E1s for the case of a single atom. Here this E1s orbital energy level is modified in form of an energy band which is having the variation of energy from a lower value to a higher value. That means all electrons which are having energy between the value L to H are all allowed to move or all allowed to exist in the 1s energy band corresponding to this nucleus. Similarly, its 2s energy level will also be changed or modified in form of 2s energy band, which will be having a lower value and a higher value of energy. And 2p will also split, and so on we can say, because due to the existence of surrounding nuclei, the energy of electron which is in the influence of one nuclei will get modified. So in this situation, every energy level for each atom will be modified in form of an energy band in which electrons not of any specified energy but in a small range of energy can exist in this region, and this region we can call 1s energy band, 2s energy band, and so on. If we just have a look on a physical situation, here you can see this picture. In this picture you can see a similar situation which we explain in the above diagrams. This is energy level diagram for a single atom. Here we can see the energy levels corresponding to orbitals 1s, 2s, 2p, 3s, 3p, and so on. And in case of a solid lattice, you can see these orbitals are modified in form of energy bands. Here you can see that 1s orbital corresponds to a very thin energy band, or almost like the energy level, because 1s is so close to a nucleus that the effect of surrounding nuclei on this electron, which is in 1s orbital, is almost negligible. So it won't get very much modified. Here we can see that as we move away from the nucleus or we move towards higher orbitals, the modification in energy band or thickness of band increases, because as electron moves away from the nucleus, it comes more in the influence of surrounding nuclei. That's why the modification of bands in higher orbitals is more. Even at a very high level, we can see that these energy bands of adjoining orbitals get overlapped also. So, in case of solid lattice, we can say that energy levels of atoms are modified in form of energy bands. I would advise all the students to just keep this concept always in your mind whenever you are dealing with any problem or analysis related to semiconductors, because in the coming sections we are going to discuss about semiconductors, where this concept is quite important to understand.